Hello, everyone, and thank you for joining us for today's webinar titled Demystifying Machine Learning and Measuring SOC Success. My name is Lucy Buckley, and I'm the Product Development Specialist here at ISACA. We have a great presentation in store for you, thanks to our sponsor, LogRhythm. Before we get started, I'd like to go through a few quick tips. You have two audio options. One is to listen over your computer speakers, or two, you may dial in at any time using the numbers and codes listed to the left. If you're having any audio issues, please dial in now. All ISACA members can receive 1 CPE credit for viewing today's webinar. If you're watching the event live, you must complete 3 attendance checkpoints. Simply click OK on the pop-ups that appear on your screen. Click on the Credits tab at the top of your screen to track your completed checkpoints. If you're watching the on-demand recorded version of this event, your progress is being tracked by the system, and you must watch from the beginning to the very end of the recording in order to receive access to the survey. After completing the webinar, you can receive your CPE certificate by visiting the transcript page within your My Learning portal. Please remember, it will take 24 hours for the CPE credit to appear in your ISACA profile. We have made a CPE submission aid that goes over these steps in more detail. Click on the Papers tab at the top of the window for more detailed instructions or to download a PDF of today's presentation. Our speaker will be conducting a Q&A session towards the end of the event, so if at any point you have a question, please click on the Q&A tab. If at any time you need technical support, please access the Help tab. Finally, if you have any questions about CPE submission process or suggestions regarding our webinar series, please visit support.isaca.org. And now I'm very excited to be introducing everyone to today's speaker, Mr. Andrew Hollister. Andrew, Senior Director, Sales Engineer, and LogRhythm Labs, oversees technical resources for the region to advance LogRhythm's vision of providing an unrivaled next-gen SIEM platform. He studies the threat landscape to understand how customers can leverage analytics within the LogRhythm platform to detect and respond to cyber threats. For over 20 years, Andrew has had the opportunity to work in a variety of IT consulting roles, working within the private and public sectors, including SEM, DLP, and application-level firewall design and implementation. Andrew joined the LogRhythm team in 2012 and has a keen interest in machine analytics. All right, everyone, let's get started. Andrew, I'll let you take it from here.
Great. Thanks very much, Lucy, and thanks everybody for joining our webinar this morning. As Lucy said, the webinar is about demystifying machine learning and measuring SOC success. And we have to say we're living in a very interesting kind of time in these areas of technology where artificial intelligence and machine learning are having an influence in every aspect of life. And, you know, everything from self-driving cars through to medical developments leveraging machine learning and AI. And of course, it's natural that we should look to these kind of developing technologies to help us in the cyber arena as well. And there's a number of things that are driving that. It's the breadth of attacks that we're seeing, but it's also really driven by the lack of skilled staff, the difficulty in recruiting appropriately skilled staff for our security operations centers and otherwise, and the resulting need to automate. So today I want to talk initially a little bit about the brief history of AI, the context of where we are today, a bit about the hype and the reality around machine learning and AI, a bit about the data science that's behind it and around the domain and drivers there, and finally what machine learning can give us and how we measure improvement in our security operations. So perhaps to get us started, maybe we'll just look at a couple of definitions. so that we're at least using the same terms and we know we're talking about the same thing. So data science itself, this is the discipline of extracting information from data. And data science is really quite a broad field that also includes machine learning. And machine learning, this is really the science of enabling computers to learn without being explicitly programmed to do something specific. And much of what we've done with computers historically has been around giving them some instructions. If this happens, then do that, and so on and so forth. And machine learning is much more around enabling machines to apply statistics and algorithms at scale on large amounts of data. And one of the goals for machine learning is actually to help achieve artificial intelligence. And when we look around the industry, then we see there's often these kind of two terms, machine learning and artificial intelligence, are often mixed up. And it's actually the case that machine learning helps deliver artificial intelligence. They're not one and the same thing. So finally, kind of getting on to artificial intelligence, this is really the science of enabling a computer to automate something that a human being would normally do. And you know, this isn't a if then do something else, do something else. This is something that requires intelligence, some analysis, kind of almost human cognition and decision making in order to do something. So that's just some definitions that hopefully will help us in our as we go further in the webinar. Now, if you're all standing in the room with me, I'd ask you to raise your hands as to who recognizes this movie image. But since you're not, I'll just ask it rhetorically anyway. This, of course, is HAL, the brilliant but ultimately uncontrollable computer mind represented by this glowing red orb from Arthur C. Clarke's 2001: A Space Odyssey. And the kind of interesting thing with this, I guess, is Arthur Clarke wrote A Space Odyssey actually 50 years ago this year. And he kind of envisaged artificial intelligence and a machine that actually had its own cognitive ability. But yet here we are, 50 years later, it's 2018, and we're here talking about how AI and machine learning are going to be big soon. So, you know, Clarke thought by 2001 we'd be exploring the kind of deep recesses of space, and we'd be doing so with AI at the helm. And, you know, it's a bit unfortunate and perhaps a bit disappointing for many of us that actually hasn't come true yet. But nonetheless, it's interesting to look at, you know, what developments there have been. And if we go back to the kind of dawn of AI, I guess it was really in the 1940s. We had these kind of foundational ideas in computation and intelligence. You had Turing and his Turing machine. World War II really drove innovation in this field. And as early as 1947, Turing was predicting machine learning and the rise of artificial intelligence. And, you know, as we kind of moved on into the 50s and 60s, there's a lot of enthusiasm around this space, and not least it was really embraced by science fiction writers. And you also had, in addition to Arthur C. Clarke, you had Isaac Asimov in his I, Robot work of fiction in 1950, and he was predicting and imagining, you know, what would the world be like if robots and smart machines coexisted with human beings. And kind of after all that excitement and kind of early innovation and kind of forward-looking in this space, during the 70s, a little bit of an AI winter, really. There's a lot of pessimism due to the lack of progress. We didn't really have the computing power or the storage to do what we needed to do, and a lot of the funding kind of really dried up in this period. And it wasn't really until the 80s AI kind of returned, but it was more in the form of what we might call narrow or weak AI, where the focus was really on enabling a specific task and trying to develop AI in that space. And, you know, compute power began to become much more accessible. You had the workstation, you might remember the Sun workstations and so on that came out at that time. And AI started to be measured really in terms of, what can we do with this? How can we measure the development of AI? And one of the measures was looking at something like a strategy game, and chess obviously suited this purpose very well. And you'll remember the kind of competition between IBM's Deep Blue and Garry Kasparov, and after several rounds of that competition, we got an AI that was actually able to beat a human being at a fairly structured strategic type game. 2000s, again, we continued to see the rise of cheap, powerful compute resources, and combined with kind of the rise of big data, some more storage and compute power generally, and that really laid the foundations for the rise of what we more and more see today as modern ML. And as we look at today and beyond, we are really beginning to see AI disrupting most industries. As I mentioned, anything from self-driving cars through to medical advances. We're seeing AI, and by extension ML, really being developed in that space. And I think one of the most interesting things here is we had the Deep Blue versus Garry Kasparov for the chess championships, and in 2016 Google developed AlphaGo, a machine to actually play the game of Go, which is recognized as one of the most difficult strategy games that exist. And Google set their AI up against the world champion in Go, and the interesting thing was Google's machine didn't just kind of use brute force computational power, which was what was happening with Deep Blue. It actually learned different kinds of moves, and according to the Go community, in that competition, Google's machine AlphaGo actually developed new moves that had never been used before in the game of Go. And rather than just using brute force, it was actually beginning to leverage all this data and do something that required intelligence and decision making in order to get to that result. So, we've seen over the course of the last 60, 70 years, I suppose, many different kinds of developments, both in narrow AI and now towards stronger AI, and we continue to see this development going on. So let's talk a little bit then about the kind of hype and the reality. And you can almost say it's perhaps a little bit similar to the early days of AI and ML in the 50s and 60s. This is really exciting, it's cool, but is ML AI going to be the security silver bullet for us? Perhaps if we read some of the marketing materials, we might well think it is. And we're looking at ML and AI. It's going to learn all the patterns in our environment. It's going to recognize and surface all of the real security concerns. There'll be no false positives, and the problem's completely solved, right? We're making some developments in that direction, and I think the reality is, there's a lot of debate around vendor claims of the kind of magic bullet of machine learning for cybersecurity, and the reality is there's nothing such as a magic bullet for security. There are technologies, and certainly this technology can help us as it develops, and as the space develops and our understanding of it develops, it can actually help us to move forward in our kind of fight against the threats that we see in our environments. And the actual reality is that machine learning today is roughly, AI today is roughly equivalent to machine learning. And this machine learning is really most helpful in threat detection by learning patterns of normal activities and recognizing anomalies to those activities. And we have the data, and we have the compute power to be able to do that today. And, being able to notice the introduction of a new pattern, perhaps predict a new pattern coming out, changes in existing patterns, or, you know, a pattern that was in our data before that isn't there anymore. But, you know, the reality is the fully enabled AI SOC doesn't yet exist today. But perhaps a more realistic short-term goal is applying a machine learning pattern recognition to automatically link a threat model from, say, 6 weeks ago to a similar one today. That's really a realistic goal of what AI machine learning can deliver to us today. And you know, given the sheer volume of activities that are taking place in today's systems and applications, and you know, when you look at the IT environment that you work in, you know, perhaps some years ago you had a laptop or a desktop on your desk, and you had some servers in a server room or a data center if you're a larger organization. Today, very likely you've still got those things, but you've also got cloud-based SaaS services. You've perhaps got Office 365 or Google Apps for email or these kind of things. So there's really a breadth of applications, a breadth of systems that we perhaps weren't seeing before. And of course, in this space, we get to see what's going on through log data, ultimately data about what's taking place in their environment. And machine learning's pattern recognition and predictive capabilities across this vast sea of data have really become incredibly important. So let's talk a little bit more in detail about the key success factors in applying artificial intelligence and machine learning. And you know, the reality is machine learning is really completely 100% dependent on the data and the quality of the data. And you know, to that point, you can have the most fantastic machine learning algorithms, the most fantastic data scientists working on those algorithms, but ultimately, if it's garbage in, it's going to be garbage out, and the best algorithms in the world are really not going to, and the most compute power in the world are really not going to solve that problem for you. And when we look at data science in general, a good part of data science is really the data preparation before we get to the algorithmic and statistical piece. And this is really about accessing, organizing, and structuring the data assets that are going to eventually be used for our data analysis. And research shows that actually today data scientists spend anything up to 80% of their time actually preparing data, and only about 20% of it actually working with algorithms and running models and so on and so forth. And of course, this is a big challenge. If all my time is around organizing and structuring this data, it's limited what kind of value I'm actually going to be able to get from it. And you know, if we think about the space that we're in cybersecurity, as I mentioned, most of our data comes from logs in and around our environment, whether that's from our endpoints, our network, our server systems, or perhaps a SaaS-hosted application. The information about what's going on from a security or operations perspective really comes in the form of log data. And I'm showing now in the presentation a pretty simple log. It's from a specific application, but even with this pretty short and simple log, there's a lot of questions about what's actually contained here. And if we just focus on the kind of the 3 W's, the when, the what, and the who, and start with the when, you know, we've got 2 things in here that look like date timestamps. We'd have to inherently know, if I'm going to throw this into a machine learning algorithm, if I'm going to throw this into something that I want to be turned into or fed into something that's going to give me some results, then, you know, I actually have to know which one of these represents the time that I'm looking for. Is it the time collected? Is it the time generated? What time zone is this in? You know, if we move on to the what, you know, is this an application log? What kind of application is this actually? And, you know, we've got an event ID 001 in here. What does that mean? Do I know? Does it matter? Is it a success message? Is it a failure message? There's actually not enough data in the log itself to tell me that information. And again, if we look at the who, you know, there's some IP addresses here, there's some host names, there's some usernames, you know, which one is source, which one is destination, and so on and so forth. And, you know, so far all we've talked about is 3 elements of this particular kind of log. There's a whole raft of other information here that we haven't even talked about yet. And, you know, this kind of really illustrates that there is a challenge around this space of taking this data, turning it into something useful that we can actually do something with. So I'm just going to have a little look about how we at LogRhythm address this kind of problem space and give you a bit of an example of data preparation in action. And the way we've gone about this is really through a strongly defined data structure and taxonomy. And the idea here is to pull all that useful data out of the log, to interpret it, and to classify it with plain English technology agnostic descriptions. And you can see here, for example, you know, we have 3 high-level classification types. So a log is either operations, audit, or security. And then we break that down further into specific classifications, and in this particular example, this log has a classification of access granted. And then within that classification, then we break it down further into common events, which is a much more low-level specific descriptor of exactly what is this what is this log doing? What's it telling me? It's giving me we're giving it a more granular level of data intelligence here. And finally, you've got the kind of actual underlying normalization rules. There's 600,000 of them here, and this is just a short kind of clip of them. You need kind of 3 or 4 screens high to show all the rules that come under these common events here. And really, this kind of broad to fine-grained level of data intelligence is the foundation that really makes machine learning actually possible. And without this data processing, without picking the eyes out of that data and being able to know which field is the source, destination, and so on, you're not even really going to get started on your machine learning approaches. Okay, so we talked a little bit about the kind of data and data preparation side of it. Let's talk a little bit around the kind of domain that we're in here. And if we think about, you know, why is it that security teams have such an urgent need to automate the detection of threats and of malicious behavior? And the reality is, you know, attackers continue to develop their approaches, and we as defenders have to continue to develop our approaches too. And, you know, if you've been in this space for a while, then you'll have heard this idea that, you know, the attacker only has to get lucky once. They've only got to find that kind of one vulnerability or one configuration that you miss. The defenders have got to be, quote unquote, lucky all the time. And, you know, perhaps we've actually got an opportunity here with machine learning approaches that we actually only have to surface one anomaly in behavior in our environment that perhaps can lead to exposing the whole attack. And you know, perhaps the defenders actually get a bit of a leg up here and get the chance to kind of get lucky once and show up exactly what the attacker is actually up to. So I'm just going to take a pause for breath there a second, and we can bring up our first poll, if you would, Lucy. So in this poll, we are asking, out of these things, what concerns you the most? So account compromise, insider threats, privileged account abuse, data exfiltration, or it's something else. It's none of the above. So while you answer that, excuse me, I'll carry on with the next couple of slides, and we'll come back to it when the results are in. So let's just talk a little bit about the evolving needs around security more generally. And as we know, there's an exponentially increasing threat surface, and I'm not going to labor the details. You're all security people here. We're seeing the Internet of Things. We're seeing, as I've already mentioned, software as a service, platform as a service, and so on and so forth. And we're also seeing a very wide spectrum of attacks. And they've coined this phrase "unknown unknowns." There's certain types of attacks we know and understand very well. There's others that are much more innovative, and perhaps we haven't seen that kind of approach before. And we have to consider all these different types of attacks. Improving our detection actually requires both improving our accuracy, but also improving our efficiency. And this is perhaps where we can most leverage machine learning approaches to help us grind through all this vast quantity of data that we have to look for. And that really requires us to move beyond a simple rules-based approach. And we've just got this quote from Keith Weiss, the head of US software coverage for Morgan Stanley here. And, perhaps our historical approach has just been kind of layering one type of technology on another and having many different types of technology. It's very complex, it's expensive, and the reality is, we're not actually winning the fight here. Losses related to cybercrime have nearly doubled in the last 5 years. And in terms of that, we need to leverage software platforms that are actually going to help us achieve the ends that we need and improve that detection and response rate. So just looking at some of the things that are kind of driving this interest in ML around security specifically, I've read the Verizon data breaches investigation reports for a number of years now. They've been doing them for quite a few years, and it's interesting to see how these different statistics progress over time. And this year, 69% of organizations reported a recent insider data exfiltration attempt. And I guess the kind of interesting thing is an insider, it's not easily defined with rules. If you're looking at an attacker, perhaps they're going to try and brute force a password, they're going to try and find a way through your firewall and so on and so forth. You've really got a number of activities there that are quite easily defined and defined through behavior or scenario-based, rule-based rules to capture them. If we've got an insider who's actually trying to exfiltrate data, that's a much bigger challenge. That's not easily defined by rules because this individual's got access to the system already. They use perhaps all kinds of different parts of your server infrastructure or your SaaS software offerings that you're using. It's not easy to define, well, actually this user, but by rules, that this user's doing something different. And that's really where perhaps machine learning can come in and help us with more behavior type-based profiling. Just moving on here, 81% of breaches in the last year involve stolen or weak credentials. And, this is really kind of to the same point. If you've got valid credentials in an environment, on a rules-based system, how do you capture unusual behavior? To some extent, maybe if you start creating some new accounts, you start deleting a lot of data or things like that, maybe that's detectable, but subtle changes in behavior because someone different is using the credentials, that's much more difficult to detect in that way. And I guess the third piece here really is around the cybersecurity skills gap. And CyberEdge's 2018 Cyber Threat Defense Report found that 8 out of 10 organizations reported they were being affected by the cybersecurity skills gap. They couldn't actually hire the people that they needed, whether it was security administrators, whether it was security operations center staff, and so on and so forth, that they actually needed in order to defend their organizations. And, when you've got a skills shortage, you can't hire the people that you need. then the approach has got to be, well, perhaps we've got to get the technology to do some of this for us. And that's one of the big drivers here. Okay, so let's have a look at the poll results here. Okay, so we can see here we've got 22% of you were most concerned with account compromise. 35% of you were most concerned with insider threats. 28% with privileged account abuse, and 15% with data exfiltration. And I think this really kind of illustrates the point. This space with insider threats, what my internal users are doing, and how they're using resources, and how I detect. Yesterday this user was a regular guy who was kind of doing his job and contributing to the goals of the company. Today, either by coercion or by bribery or for some other reason, he's actually turned into an insider, and being able to surface those kind of anomalies and changes in activity is really where machine learning excels in this kind of space. Okay, so thanks for your input there, everybody. Let's kind of move on and talk a bit about the kind of broader security analytics machine learning landscape. And there's a number of broad areas or approaches, I guess, to machine learning, and this goes kind of from anomaly detection and behavioral profiling through to things like peer analysis and network analytics and so on and so forth. And the fact is, many different kinds of algorithms may be used to deliver these different detection approaches. And one of the key things here is we don't want our SOC analysts to have to be kind of advanced statisticians to leverage them. But we should be aware there are many approaches to solve this problem. But having the right data to put into these algorithms is just important as choosing the right algorithm or the right statistical approach. And these machine learning approaches enable the machine to analyze the data from many different angles and in many different ways, really in order to surface subtle changes, for example, in the user behavior, perhaps comparing an individual to their own historic behavior, or perhaps indeed comparing them to their peers. And this group of individuals typically behave similarly, and this one individual, their overall behavior pattern is now looking different to those people who have been their peers historically. Well, we can actually surface that kind of anomaly through machine learning approaches. And that kind of takes us quite neatly on to what is it that machine learning really actually gives to us. And Gartner have coined this kind of certainty versus insight paradox. And there's some users, they really don't want false positives, they want certainty. And the reality is certainty is pretty well binary. Then that drives me in a kind of rules-based direction. If I see this behavior followed by that, or this activity followed by that activity, and these two or three things in a row, then raise me an alert, I know that's something of concern in my environment. But for other users, they want insights into threats that they wouldn't otherwise know about. And this is really where machine learning is giving us much more, something that's much more aligned to insight rather than uncertainty. This activity is unusual, it's anomalous, it's different, but ultimately we need human eyes on it. The machine learning can give us that information. This is anomalous. We need human eyes on it to say, hey, you know what, this is anomalous, but actually it's because the user's changed job roles, or there's been a change in the business in some way, or indeed, yes, it's anomalous and corroborated with the other information that we know in our environment. We're going to open an investigation and find out what's going on here. And when you think about this kind of certainty insight paradox, if you take, for example, the user behavior space and monitoring either privileged users or regular users in your environment, there are a whole raft of use cases that are easily defined using scenarios. And you get a binary answer, this either happened or it didn't. But, you know, this user who's perhaps being bribed or a user whose credentials have been compromised, when they start behaving in different ways, you can't really describe that with rules. You can't describe it with a scenario. You need something that can surface changes in the way they behave in the environment. And therefore, I would argue you actually need both of these, and you have to accept there's going to be a level of uncertainty when you're going to surface insights into threats you wouldn't otherwise know about. And really, just to underline that point, machine learning is all about non-deterministic logic. You know, we can provide an output, but we can't perhaps fully explain what the decisions are. And this isn't because of a design flaw or bad implementation, but it's inherent in this space. You know, if I could describe it, well, that would be a rule. We're actually using advanced math and statistical analysis here, so in a sense we shouldn't be able to describe it. And each individual decision can't easily be explained, and this was very well illustrated by the Google DeepMind AlphaGo machine. The developers couldn't explain why has the machine decided to do that. It's gone through its algorithms, it's taken all the data it's got, it's come up with a result. And really in this space you've got this kind of three-way triangle of it being correct, explainable and fast, and really you can only have two of those together. And you know, we obviously want the output to be correct, we want it to be quick, but that's really at the cost of it being explainable. And ultimately a non-deterministic approach is always going to augment a deterministic approach. And, you know, what we mean by that is a rule-based approach provides certainty over insights. So let's just talk a little bit more about why we might want to adopt both approaches before we move on to talking about the SOC itself. You know, we see a very broad spectrum of attacks, anything from a brute force and commodity malware through to insider threats that we've been discussing and 0 days. When we look at such a broad spectrum of attacks, defense in depth and by extension analytics in depth is really required, and your organization is confronted by very diverse attack techniques, and these techniques range in vulnerability, method and velocity, and they fall all along this spectrum here. And in order to keep the organization safe, you need to apply analytics in depth, and you know, detecting threats that use established and known tactics, techniques and procedures, you need real-time scenario-based analytics for that. But in order to detect or catch unknown threats, then you need more advanced analytical capabilities. And the best approach to get analytics in depth is to provide both of these approaches side by side. And, you know, in some areas, this is almost a religious argument. You know, I don't want rules-based. I want anomaly detection via machine learning, and it's got to be AI and so on and so forth. But, you know, the reality is we want the system to be able to tell us as quickly as possible about those threats that represent risk to our environment. And, you know, when we think about these kind of attacks, the vast majority of attacks that we see are known, and the impact of those known attacks, you know, very high percentage of them, perhaps it's quite low. Very often the impact of previously unknown attacks can be quite high, and perhaps the attackers moving around unnoticed and can achieve their aims without being stopped. And that's what we're really looking at here. We need to be able to cover both of those scenarios. So that's kind of a quick tour of machine learning in the cybersecurity space. But, you know, there's no point in having technology just for technology's sake. machine learning is an interesting space. It's very exciting to see where it's going to go, but what value does it actually deliver? And the fact is, you can't really measure what you don't see. And the question is, what measurements should we use, and what is it that we're really looking to measure here? And ultimately, our organizations need to see the business value that they're getting from implementing, for example, machine learning or any other technology. Come to that. Is it interesting? Yeah, of course it is. But is it useful? Let's measure it and actually find out. That brings us on to our second poll. And this is really around how do you measure your SOC effectiveness today? Do you do it based on the count of alerts, the count of cases that are closed, perhaps on some wider SLAs that you've established that are being met or not? Do you measure the time to triage? Have you got no effective way to measure, or perhaps you don't know? So again, I'll give a few minutes to answer the poll while I move on to the next couple of slides, and then we'll come back to it in a second. Okay, so in terms of measuring SOC effectiveness, just looking at a couple of approaches here. You might base your measurement of your SOC effectiveness on the number of alerts, the open and close rates, and the percentage of met SLAs. And, of course, that's helpful in understanding the frequencies, how many alerts am I getting, when are things open and close, how often is that, how many. That really helps me to measure my team, and perhaps this is really based on the traditional kind of ticketing approach. The challenge from a SOC perspective is this doesn't really indicate issues, or it doesn't surface the issues that you've perhaps got in your processes, doesn't surface kind of false positive rates and stuff, and it's really a poor reflection. Just counting the number of alerts is not really a good reflection of overall performance in the SOC and how effective it's being. We could also look, for example, at something like the mean time to triage. So, how quickly the team can actually respond to new concerns. And, that's also very interesting. But again, this doesn't really recognize there's issues with false positives or even your ability to respond, or how effective am I at responding at, this kind of threat type versus that kind of threat type. So, there's kind of a couple of different approaches here, but there's obviously some challenges with both those approaches. And the way that we look at this at LogRhythm is really around measuring the end-to-end security operation process. And we call this the threat lifecycle management framework. And it starts with the earliest evidence, so that the kind of first logs that were collected that were kind of involved in the alert or what was going on. And it goes through the alarm creation, that alarm being opened, assessing whether this is a qualified threat or not, to it being mitigated and resolved. And really what we want to be able to do is measure this in a very detailed way from each part. So we've got our time to triage, we've got our time to detect, we've got our time to qualify from when the alarm was actually raised until somebody had kind of thoroughly evaluated it. You've got our time to investigate, through to the point at which I take steps of mitigation. And then we've got our overall time to respond from when that alarm was first raised right through to the point where that's fully resolved. And, in order to effectively measure our security operations processes, we want to get down to being able to work out what are the mean times it takes me to respond by the threat type. What are the mean times it takes me to qualify out a false positive? And in order to do that, we really need to get down to the task level. And obviously, the idea is we want to reduce the mean time to detect, reduce the mean time to investigate and respond. And machine learning approaches can really help us accelerate both our triage, our detection, our qualification and investigation. And by surfacing anomalies in the data that we see by surfacing changes in behavior from a user, I can actually, I get an alarm saying there's some unusual behavior. I can go and validate that against the outputs of my machine learning and say, well, actually, this user's behavior is very highly anomalous, in addition to the fact that my rules-based engine has told me there's something slightly unusual that's happened, that it actually helps me to qualify out that threat much more quickly, so that, again, I can deal with that before perhaps the insider gets to a place where they can exfiltrate the data, or they damage my organization in some other way. So again, the results are in from the second survey here, and there's kind of quite a wide variety of responses here, as you see. A number who are counting up the number of alerts that they see. Some based on case closed. The majority here have got wider SLAs that are met, which you would really expect on the whole. If I've established a SOC, I've also established some kind of way to measure those SLAs. And again, as we've talked about, it's perhaps a valuable way of measuring how quickly can I respond to cases, but without going down to this deeper level of detail, I'm perhaps a little bit blind to the actual process, the effectiveness of the processes that we've got there. And, really to that point, what we're looking for here is to make, we're not trying to make the people faster, we're actually trying to make the processes more effective and provide the people with the information that they need in order to successfully follow that process. And, when we think about kind of measuring our SOC, it is really all about making the process efficient and understanding where's the bottleneck then? What's actually kind of slowing me down when I triage this particular kind of incident? It's actually much slower than some of the other incidents. Why is that? What's the reasons around that? And, let's say, for example, we've got a very high number of alarms. Perhaps this is a technology issue. Perhaps many of the alarms aren't really qualified, and we need to tune our analytics a bit to draw down the false positive rate. Perhaps it's a slow rate of qualification. And again, maybe that's a process issue. Perhaps we can automate the collection of internal or external contextual data, maybe through some automation and orchestration capabilities. Maybe it's a technology issue. You don't actually have access to the right kinds of contextual data, whether that's vulnerability state or threat intel and so on and so forth. And, finally here, maybe it's a slow rate of investigation. And again, maybe that's a technology issue that I don't have access to the right kind of data from the endpoint or from the network. Or, it could well be, it's not written here, but, perhaps it could be a training issue. I actually need to upskill my staff somewhat to help them understand where to go for their investigations. Okay, so let's just kind of wrap up with some a few key takeaways here. True AI isn't here just as yet, at least not for network security. You can make your own judgments in other spaces, but machine learning is certainly well on the way. That said, machine learning is not a silver bullet for all of our security needs. It's certainly a very good approach to augment a scenario-based analytics that we already had, and can surface those hard-to-find activities that have perhaps flown under the radar so far. And to that point, there's no point in getting into a kind of religious argument about scenario versus behavior-based approaches. They're actually both required. They're good at different problem spaces, and if you really want analytics in depth, then you're going to want to leverage both approaches. And finally, if we're going to measure our security operations, we really should be measuring them for bottlenecks rather than frequencies or the count of number of alerts and so on, so that we can actually help those individual SOC analysts, we can help those individual threat types be responded to and dealt with more quickly, and obviously, ultimately, the goal is to keep our organization safe. Okay, well, I hope that's been interesting for everybody. I'm going to hand over back to Lucy for now, and thanks for your attention.
Thank you so much, Andrew. Looks like we have a couple of questions from the audience. The first question we have here is, what would you say are the key requirements for machine learning to be effective?
Yeah, I think, as I alluded to a bit earlier in the presentation, I think one of the key things is really it's a garbage in, garbage out. If I've just got a huge pile of unstructured data that I haven't really curated in any way, it's going to be a big challenge to get something useful out of that. And ultimately, maybe I can get my machine learning algorithms to work with that data, but the question is it really learning the right lessons, and is the output that's appropriate actually coming out? And that's really the key pillar that the whole of machine learning rests on, I would say.
Thank you so much. Here's another one from the audience. What are the recommended controls to put in place apart from awareness to deal with the insider threat?
So I guess there's a number of things here, and again, as I alluded to in the presentation, the insider threat is an interesting challenge, because you're obviously inherently talking about individuals who, to some extent or the other, are already trusted in my environment. They've got access to the resources, and awareness is one thing, and I've seen organizations with kind of internal awareness programs and so on and so forth, but really being able to get a behavior-based, profiling-based approach to both the kind of user activity and the network activity in my environment, and understand, this is what normal looks like. This is what normal looks like for this kind of individual who does these kinds of activities within my organization. Then that really gives me the basis to surface any unusual activities or any unusual behavior of that individual. And that's, in a way, that's kind of a much broader program, but that's certainly where I would be looking to more behavioral based technologies to help me with that.
Thank you so much, Andrew. Here's another one. Do you think we'll ever achieve true AI in the SOC? Is that not a bit of a marketing speak?
Good question. I guess this is the way technology has developed over the years, and I go back to the kind of excitement around all this in the 50s and 60s. There was a lot of interest, there was a lot of excitement, people had great expectations for it, but the kind of reality came in. They didn't have the compute power, they didn't have the kind of storage and so on that they needed in order to achieve that. It kind of dropped off in the 70s for that reason. I think where we are today, we've got the compute power, we've got the data storage, we've got the tools that we need in order to achieve this. And I think the realistic, a fully automated AI-based SOC in the next few years, I don't think we're anywhere close to that. But you've got a realistic aspiration of being able to kind of build or feed into, through machine learning, a threat model or multiple threat models that the machine can actually begin to make some intelligent decisions with, and understand how that's kind of developed over time, and perhaps how that relates to other models. That I certainly foresee. But I think a kind of fully automated AI-driven SOC is a very long way off.
Great. Here's another one from the audience. Can you comment a final interpretation of results when it comes to the usage of ML AI? who and how?
Yeah, that's a really good question, and you know, I think in this space, obviously there's a lot of approaches with ML, and you know, lots of different algorithms, and there's lots of intelligent people working very hard in this space and trying to develop kind of machine learning algorithms and statistical approaches and leverage them and so on. And you know, the really key piece of it is, how do I turn that into something that actually helps my SOC analyst? Because you know, I can run a whole bunch of algorithms and I get a numerical output. What does it mean? And being able to turn that into, you know, a risk-based score, being able to provide some text-based commentary to an analyst in my SOC that actually says, well, you know, this is the output, this is the risk score, and what we think it actually means is X, Y, and Z. You know, that's really the big piece that technology vendors have got to deal with in terms of the what their offerings are, because you know, our SOC analysts need something beyond just a number or a direct output of an algorithm, and that's really where these kind of three domains that I talked about, the data, the kind of cybersecurity domain, and the data science itself, you really need experts in all three of those areas working together in order to come out with meaningful and helpful information from a machine learning algorithm in a security environment.
Excellent answer. Here's another one. How dependent upon the ability to create is, I have another question for you. Is the positioning within the speed, accuracy, and explainability matrix different depending on risk appetite or organizations? How does this affect adoption?
Yeah, so this was the kind of three-way triangle we had there. And yes, I think it really does depend on the risk appetite, because ultimately you've got to make this trade-off between, is this, you know, I don't want false positives, but I want to know about unusual behavior. And when we look at the kind of machine learning field, to a great extent, what we're talking about is anomalous behavior, anomalous patterns. This is what this user normally looks like. This is how this user normally looks compared to their peers. And, you know, at what level do I want that actually to bubble up to the SOC analyst for investigation? You know, what we don't want to do with machine learning is turn it into a, you know, additional noise in the SOC, and where organizations are having to deal with even more alerts. You know, that's not where we want to get to, but a mature, an organization that already has a mature SOC process might well say, actually, I'd like to know about anomalies a little more sooner than perhaps some other organizations, because I've got a more proactive approach. I've perhaps got time carved out for some of my SOC analysts to do things like threat hunting, and I actually want to surface those anomalies earlier in order to kind of manage my risk. So I think there is some dependency on the risk appetite there.
Thank you. Okay, we have time for one more question. What can I do with the results that machine learning gives us?
Yeah, so again, I think this probably ties in quite well with the earlier question, that it's all about what the output of the machine learning algorithms actually look like, and that's where vendors today really need to invest time and effort in order to, you know, when those results come out, they come out in a way and with information that actually helps the SOC analyst in their efforts to triage and resolve incidents more quickly. So I think it's a very key area of focus for vendors today on what does that output look like? Is it risk scored? How does that kind of tie in with everything else that's going on in the environment? And really being able to give the SOC analysts some useful guidance for their role.
Fantastic. Thank you so much. It looks like we're just about out of time. Andrew, thank you for taking the time to speak with us in that great presentation and very informational Q&A session.
Cool. Thanks, Lucy.
Of course. I'd also like to thank our sponsor, LogRhythm, who has made it possible for ISACA to offer this event free of charge to our constituents. Remember to check out the tabs at the top of the window to view additional resources, to download a PDF of today's presentation and some additional resources provided by LogRhythm. The webinar was recorded, so you can go back and watch it from the on-demand program section in your classroom within the My Learning portal. Again, I'd like to thank our sponsor, LogRhythm, and their amazing speaker, Andrew Hollister, for his time and expertise today, along with everyone in our live audience for your attention and participation. Please have a great rest of your day.